Welcome back. Let's take a moment to review Trigonometry Worksheet 1. In our first triangle here, we're going to solve for the 6 trigonometric functions for angles A and B. Okay, many of you found that this was a 9, 12, 15 or a 3, 4, 5 right triangle. So with trig, we can just use the base sides. We don't use 9, 12, and 15. We can use the base Pythagorean triple. So if we're working from angle A, we're going to find the sine of A and the cosine of angle A and the tangent of angle A. So one of the things that was missing was many of you guys were not indicating which angle you were working from. So you do have to tell your reader what angle you're working from. So sine of angle A, sine is opposite over hypotenuse. So if we work from A, the opposite is 4, the hypotenuse is 5. So the sine of angle A is 4 over 5. And then your reciprocal functions, the reciprocal of sine is cosecant, and I did it again, so cosecant of angle A is 5 over 4. Okay, and so forth. I'm not going to run through all of those, but make sure you indicate what angle you're working from, so then when you move on to angle B, then we know the sine of angle B is, so if we're working from B, and that's our reference angle, opposite over hypotenuse, we get 3 over 5. Okay, so make sure you indicate the angle that you're working from. Okay, in the second one, guys did pretty well on this. We're solving for the hypotenuse. 16 is 8 times 2, and 30 is 15 times 2. So our hypotenuse is something times 2, and this is an 8, 15, 17. So we can use 8 and 15 and 17 as our basis. And again, just remember to indicate which angle you're working from. So if we want to find the tangent of angle P, that's what we would do. So we're working from our reference P. Tangent is opposite over adjacent, and that would be 8 over 15. Okay? Now, if you did do the tangent of angle P, and you use 16 over 30, that's close but not quite right. Make sure you simplify your fractions. Okay. And then for the 30, 60, 90, please make sure you label your triangle with its sides and angles. Okay. And in a 30, 60, 90, we have 1x or x. Opposite the 60 is the x root 3. And 2x. Okay, so the sine of 30 degrees, we work from 30, our opposite over our hypotenuse would be 1x over 2x, but our x's simplify, and so that just simplifies to 1/2. Okay, so our reciprocal functions, we can do those. I'll do the cosine of 30 as well. So the cosine of 30 is the square root of 3x, because it's adjacent over hypotenuse. So square root of 3 over 2, remember your x's cancel. So that would be the cosine of 30. So then your secant of 30 is that reciprocal function. It's 2 over the square root of 3, but we have to rationalize that. No square roots in the denominator. So the secant of 30 degrees is 2 square root of 3. All over 3. Okay, so I'll leave the rest of the trig functions for you. Okay, so for the 45, 45, 90, similar kind of thing. Make sure you draw your triangle. Okay, our angles are congruent. Okay, and the sides are x, x, and our hypotenuse is x root 2. So again, the x's are going to cancel because we're going to simplify that. So the sine of 45 degrees is going to be opposite over hypotenuse. So that's x over x root 2 the x's cancel, so it really becomes 1 over the square root of 2. And then we have to rationalize square root of 2 over 2. So the sine of 45 degrees, and again we're writing our angle measure in there, is the square root of 2 over 2. So our cosecant, CSC for cosecant, our cosecant is the reciprocal, that's just the square root of 2 over 1. And then for your 6 trig functions for 60 degrees, you can refer to problem 3's triangle, but now we're just working from the 60 degree angle and not the 30. Okay, so you'll get different values here, but 1, square root of 3, and 2, I've taken the x's out, so the sine of 60 degrees, not just sine, but sine of 60, your reader's got to know where you're working from, is adjacent over hypotenuse, so it's 1 over 2. Our hypotenuse is always the hypotenuse, it's not the adjacent side. Okay, for number 6, we had to do the Pythagorean Theorem, so 2 squared plus 5 squared equals our hypotenuse squared, and we get, is that 29 equals c squared, so we get the square root of 29. And then you've got to do your 6 trig functions. So for example, the sine of angle x is, if we're working from here, angle x, our opposite, and our hypotenuse was the square root of 29. So 5 over the square root of 29, and then we have to rationalize by multiplying top and bottom by the square root of 29. So the sine of angle x is 5 square root of 29 over 29. Okay, and then for 7, that's 3.5, and 12, I really don't like the fraction of 3.5, that's really 7 halves, and 12 is the equivalent of 24 halves. So this is a 7, 24, 25. So we can use for our trig just 7, 24, and 25. So if I'm working from angle M here, and I want the tangent of angle M, I will do opposite over adjacent, which would be 7 over 24. So my cotangent of angle M is 24 over 7, and so forth. And then finally on 8, a 3, 4, 5 is not a square root of 3, square root of 4, square root of 5. Doing our Pythagorean theorem, we actually get the square root of 2. And so this one gets kind of messy. It looks like we're working from angle F here. So the sine of angle F would be the square root of 2 over the square root of 5. And this was kind of a nasty problem because we've got to rationalize everything. So we have to do the square root of 5 over the square root of 5, which gives us the square root of 10 over 5 for the sine of angle F. So you'd have to do the similar process for the rest of your trig functions for that triangle. So hopefully that answers any questions you had on SOH and the introduction to SOH and trig worksheet 1.